Hello everyone and welcome to the new episode of our series of solving LeetCode Daily challenges. And today we are going to solve a problem called non-overlapping intervals, which has a medium difficulty. So let's read the problem statement. The problem statement is quite concise. We are given an array of intervals. Each interval is defined by its start and its end, and we need to return the minimum number of intervals we need to remove to make the rest of the intervals non-overlapping. Okay, let's look through the examples. And in the examples, we can see that our intervals can have common points. So if we have two intervals, 1, 2, and 2, 3, there is no need to remove anything. We can just leave both of them. And yeah, that's pretty much everything we can get from the examples. Let's look at the constraints. So the total number of intervals is up to 100,000, and the coordinates of the intervals are between minus 50,000 and 50,000. Okay, so quite an interesting problem. Let's discuss the solution for this problem. So first thing that we are going to do is the following. Instead of calculating the minimum number of segments we should remove, let's calculate the opposite. Let's calculate the maximum number of segments we should keep. Then, if we know that, it's trivial to calculate the answer. We will just subtract this value, the maximum number of segments we should keep, from the total number of segments, and we will get the minimum number of segments we should remove. So far, so good. Okay, there are several ways to solve this problem. The first one is dynamic programming. And the attentive viewer will notice that this problem is very, very similar to the problem maximum number of events that can be attended to, which was a daily LeetCode challenge just 4 days ago. And go check out my video about this problem. And therefore, dynamic programming solution is definitely possible here. There are two differences between this problem and that problem. The first difference is not very important. The difference goes like this. So in the problem maximum number of events that can be attended, our segments were not allowed to have common points. So for example, if we had events like this, the first one started at day 1, ended at day 2, the second one started at day 2 and ended at day 3, then we could not attend both of these events. But in this problem, it's okay to actually keep both of the segments with these coordinates. We can keep 2 segments in this case. But it's not very important. It doesn't change our solution much. We just need to change some less than or equal to less than or something like that in our solution. So it's very, very similar. The other difference is super important, and it will actually allow us to solve this problem much, much easier. And the difference is that in the problem maximum number of events that can be attended to, each event or segment had a value attached to it. And we needed to maximize the total value of the events that we attended. But in here, we just want to maximize the number of segments that we keep. Therefore, it's basically this problem is equivalent to the problem where each event had a value of 1, which was not the case at all in the problem maximum number of events that can be attended to. And this difference is very crucial for us, and it will allow us to implement a much easier greedy solution instead. Okay, so what is the greedy solution for this problem? So we are going to sort all of our segments by the value of the end of this segment. And then we are going to take the segments in third order. And we are going to take as many segments as we can without allowing intersections. Okay, so what's the intuition behind such a greedy solution? So we want to ask ourselves a question. What is the leftmost segment that we want to choose? And the answer to that is the one that has the smallest possible value of the end. By doing so, we give ourselves more segments to choose from in the future, because there will be more segments that do not intersect with ours. Okay, now let me go a little bit more formal in my explanation. So suppose we want to choose some other segment with index j, and suppose that our segment is the segment with the smallest value of n, and it has a value, it has an index of I. Okay, so at first suppose that start of j is bigger than or equal to end of I. Then we can include both segments I and j to the answer, and therefore there is no need to make segment j the leftmost. We can make the segment I the leftmost, and include segment j to the answer as well. Okay, now suppose that start of j is less than end of I, and end of j is bigger than end of I. So it's like, for example, something like I is equal to interval of I is equal to, let's say, 1, 4, or interval of j rather, and interval of I is equal to 3. Okay, I'm saying that picking interval of I is more optimal, because by doing so, we leave ourselves more options in the future, because if we choose the segment 2, 3, then in the future we can choose any segment that starts from 3. But if we choose the segment 1, 4, then we can no longer choose segments that starts from 3, because they will overlap with this segment from 1 to 4. Okay, and the final case, if start of j is less than end of I, and end of j is actually equal to end of I, then we can choose either of these segments. Basically what it means, if we have several segments that end at the same point, we can choose either of them, because yeah, they are equally optimal for our future solution. Okay, so let's see how can we implement this solution. So to sum up, our solution goes like this. We sort our intervals by the value of n. We choose the leftmost, and then we just ignore all of the segments that overlap with the current segment that we have chosen, and then we choose the next one in the same sorted order that does not overlap with our current segment. And let's look at the implementation. So first of all, we have created this class interval that has two fields, start and end, and it's just a class that we're going to use for our convenience. Then we're going to create a list of intervals sorted by their end values, and to do that at first we are going to populate this list, and then we are going to sort it, and in our comparison we are going to compare only ends of our intervals. That's exactly what this statement is telling us. Okay, then now we have these sorted intervals. We are going to keep a couple of variables. The first one is the number of segments that we are going to keep, and the second one is our current interval, which initially is equal to null. Then we are going to iterate through our intervals in this sorted intervals order, and we are going to check if our current interval is equal to null, which will only happen at the beginning of iteration, or our next interval does not intersect our current interval, then we can include our next interval to the answer, and we will increment the number of segments that we keep, and we will assign our current interval to the next interval. Okay, and in the end, remember that we are calculating the number of segments to keep, but actually we want to return the number of segments that we should remove. And it's obviously equal the total number of segments minus segments that we want to keep. And that's it. Okay, so what's the complexity of this solution? The most computationally hard part of our solution is sorting. So here we do sorting. And our sorting has complexity of big O of n times logarithm of n, where n is the number of intervals. And that's the total complexity of our solution. Okay, guys, that was a very interesting problem because at the beginning you immediately think about dynamic programming solution. You think, okay, this problem is very similar to that other problem. But if you think a little bit more, you actually come up with a much easier, greedy solution that works fast and is easy to implement. I hope you liked this video. If you did, please press like, subscribe to my channel, and if you have any questions, leave them in the comment section. I will be really glad to answer them. I hope you guys have a very, very good day, and I'll see you around. Bye bye.